Hello everyone. This video is the very beginning of our new unit, Unit 6. As you can see here, the unit is called Similarity, and we have 5 sections here that we are going to discuss how to show figures, specifically triangles, how to show they're similar. So we're going to review what that means. I know you've had some similarity in the past, and we're just going to take what you already know and extend that. So we are going to start with the first section here, section 6.1. I have a little vocabulary that I'll kind of go through with you, and then we'll run through our examples. All right, first of all, similar polygons. So similar polygons is defined by 2 polygons are similar if corresponding angles are congruent and corresponding sides are proportional. Okay, really important piece here. 2 elements. Corresponding angles are congruent, number 1. Number 2 is that the corresponding sides are proportional. So, new term here. Notice it doesn't say that corresponding sides are congruent, because that would simply mean that the 2 figures were congruent. Similar has to do with one shape being larger than the other, but proportionally. So the concept of a proportion, let me just kind of briefly talk about this. 1/2 equals 4/8. This is a proportion. So a proportion is defined by 2 fractions or 2 ratios being equivalent. So in a real basic case, let me just draw part of this picture. If the side length here of this triangle were 4, let's say these triangles are similar, and the side length of this second one is 8, well, 4 and 8 would be proportional to, let's say, a second side is 2 and 4. So do you see how they're both, it's almost like the second triangle is twice as big as the first. So we're going to talk about that type of a thing throughout the whole unit. But today, what I want you to start with is that there are 2 items for similarity. Number 1, the corresponding angles have to be the same. And number 2, the corresponding sides are proportional. Scale factor. The scale factor is the ratio of the lengths of 2 corresponding sides in a similar polygon. So my scale factor on my example right here might be 8/4, which is really 2/1. Okay, so typically the one thing I want you to try to do is we are going to write scale factors as fractions. And we sometimes reduce them down. Sometimes we don't if we're trying to compare them, but when we write a final scale factor, we typically reduce it down. Okay, number 1, trapezoid ABCD is similar to trapezoid PQRS. List all pairs of congruent angles and write the ratios of corresponding sides as a statement of proportionality. So, I want to bring a new symbol in. This symbol right here is the similarity symbol. So, if I rewrote this, ABCD is similar to PQRS. So what that means is the corresponding angles are congruent. So remember, we can go off of the order of the names. So A and P come first. Excuse me. So angle A is congruent to angle P. So I'm just going to keep writing the other 3 out based on how it's listed. So angle B is congruent to angle Q. Angle C is congruent to angle R, and then the last 2 letters, angle D, congruent to angle S. Now, I can do that because I know that the shapes are similar. So the statement of proportionality, I'm just going to write the 4 sides in a ratio equal to each other. All right, so let's just start with, let me switch my colors here. let's start with segment AB and segment PQ. Now, it doesn't necessarily tell me I have to write it in a particular order. So I'm going to just start with that the length of AB, I'm going to put that into a ratio with the length of PQ. Now, because the shapes are similar, that's equal to another set of corresponding sides in a ratio. So going back to the name, I'm going to then say BC in a ratio with QR. That's equal to a third set of corresponding sides, CD over RS. And finally, I'm going to take the first and last letters of the names, AD over PS. Okay, so my statement of proportionality simply shows, first of all, this is a big proportion. A proportion, again, are two fractions equal to each other. So this is a statement of proportionality just to show that the ratio of the corresponding sides are equal. All right, let's look at number 2 here. Determine whether the polygons are similar. If they're similar, write a similarity statement, and then find the scale factor of DEFG to JKLM. Okay, how do I determine if polygons are similar? Well, I go back to the top here, right here. Polygons are similar if two conditions are met. So I'm going to check the angles, and I'm going to check the sides. All right, now it doesn't tell me that they're similar yet. So I'm going to match up the markings on the diagram. All right, so I might just start with G because it's a right angle. So I can tell that angle G is congruent to angle M. They both are 90. And then I'll just go to the single arc, the double, and the triple. So angle F is congruent to angle L, single arcs. Angle E is congruent to angle K. They both have 2 arcs. And then finally, angle D is congruent to angle J. So I have shown that the corresponding angles are congruent. Now are the corresponding sides proportional? So we need to check our ratios. So I'm going to maybe just start along the bottom with GF and ML. So let's put GF in a ratio with ML. And then I'm going to plug the numbers in. So I know it's a 12 to 16 ratio, 12/16, but let's reduce it down. So a 4 goes into both, so 3/4. So I'm looking to see, are all of them a 3/4 ratio? Okay, let's move on. Maybe I'll just do some color coding here. EF and KL are corresponding sides. So EF, KL, would be 6/8. Divide by 2, okay, would give me 3/4. So it's looking good. It's looking like these probably are similar, but let's just keep going. How about the top? DE in a ratio with JK. So I will have a 15/20, and let's hope it gets 3/4. Divide by 5, 3/4. Okay, we're probably good. One more. DGJM. So DG over JM. So notice I've started with the same polygon every single time in the numerator. I don't want to go flip things over. I need, wherever I begin, I should always begin there. 9/12. Divide by 3, okay, is 3/4. All right, so determine whether they're similar. Yes, they are. So let me just kind of put a box around here. Here's what I'm looking at. So 3/4 is clearly equal to 3/4. Therefore, these are proportional. So a similarity statement is, let's see, what I wrote right here in purple. This is a similarity statement. So I can probably just go in the same order in the directions. D, E, F, G, J, K. Yeah, it goes in the same order. So let's write that out. So my similarity statement is going to be D, E, F, G is similar to, use your symbol, J, K, L, M. And then scale factor of DEF to JKLM. So when it specifically says from this one to this one, I'm going to make sure that DEFG is in the numerator, that number, and then the JKLM. So my 3/4 is set up that way. So that is my scale factor. So scale factor is 3/4. All right, so when you are determining if it's similar, then you are most likely calculating the scale factor. All right. Okay, I think I'm going to stop this video so it doesn't get too long. And in the next video, I will go over page 2 of this lesson.